Flying like the dragon that I never ever seen. Good morning. Now, I started this, unfortunately, incorrectly because I didn't have my screen projected. Now, on my screen, I can see the space, and you can see my screen. So I need to figure it out how to use the main display. Perfect. And then this one needs to be the mirror. Yeah, perfect. Right, okay. Hello. So, I normally talk and then do a performance. I thought I'll start with a performance so you get the idea of what I do. My goal is to try and change the social perspective of programming because I think it's totally skewed in the wrong way. It's so heavily skewed towards business. I mean, how many of you work as a programmer for a business? That sucks. How many don't work for a business? Hi, right, let's talk, right? I'm not saying this is wrong, but can you imagine a world where the written language was only ever used for legal documents or religious tomes? Because that was the world, and people couldn't read and write, but the people who did read and write, so I'm still playing the music in the background, let's stop it. The people who did read and write, they were special scholars or religious scholars. And obviously now we take it for granted that we can all read and write, and we don't just use writing for legal documents. Who would want to live in that world? We use writing for letters and poems and plays and to-do lists and shopping lists and random text messages to friends. It's a beautiful tool for human expression. So why don't we do the same for code? Why is it only limited to business? And I think that's a question that we need to ask. And I think it's a deep question because it actually starts to inflect on about how we think about society as a whole. Because I don't know about you, but this is a personal problem, but when I go to parties, it's really hard to talk about what I do. You know, like you say to people, "Hi, I'm Sam. What do you do? I'm a programmer." Oh, okay. And they're gone, you know? So now I lie. I say, "I'm a musician." And they say, "Cool, what do you play?" And I say, "Code." You know? Got them. And then they've got the conversation going. And I think this is a broader problem, is that how do we actually engage with society? And I don't think that, it's like sports, right? We teach sports at schools not to make professional sports people. That's a side effect. Some people will grow up to become professional sports people, but the vast majority of people who do sports at schools, they don't become professional sports people. They still maybe continue to play some sports through their adulthood, hopefully, and keep fit, and they've got teamness, and they've got friends they can play with, and it keeps their body going, and they get some fresh air, it's all lovely stuff. But they're not learning it at school to become professional. So I think we need to think about how this works in society. Why are we teaching computer science? Why do we even bother? And I think it's really fundamentally important to do that, but I don't think it's to make the next generation of programmers. Because I think we already exist, and the people who find programming find it themselves, you know, and they do it themselves. I think the broad problem is, how do we engage with the people who are not in this room? And how could we have a conference like this where 50% of people put their hand up to say, "I'm a super interested developer, but I don't work for a business"? But what do you do? Well, what would they do? And I think they would be answering, "Well, I express myself with code." And I think that's a really interesting thing to explore. So in this sort of pursuit, I have been working on many different projects. The sort of most sort of successful one is this Sonic Pi project, which I just did that performance with. And I mean, it starts off by being looking like this, right? So this is actually the mode which is for people with low vision, so it's high contrast, nice for schools. And we start by having a blank screen, and we can write the word play and choose a number, and it makes a beep. I can make it louder. There we go. Or I can play 2 notes, or I can play 3 notes. Cool, so that's a chord. And this is the way it works, right? So the code runs at the top. I'm teaching you how to program here. Hi, if you don't know how to program, you will do after the end of the session. Although the semantics of Sonic Pi are probably not what you might expect. So although this looks like it's a sequential program, and these are executed sequentially, and this happens to be a DSL written in Ruby, those sounds are all actually sample accurately played at the same time, because there's a fancy scheduler behind the scenes. And just find this document, this one here, just to demonstrate. So I wrote this paper with Dominic and Alan quite a few years ago now, where I describe how Sonic Pi works, the plays and the sleeps that you've just seen. I haven't shown you the sleeps yet. But there's actually loads of fancy Haskell maths to demonstrate the soundness of this stuff, right? So what I'm showing you is there is deep computer science in it, but I think this is a really tricky thing to get around, because every time I speak to people about the work I'm doing, they think, well, it's really simple, so therefore it can't be complex, which kind of makes sense, because simple and complex are opposites. But what they don't really mean that. What they really mean is it's simple, therefore it can't be expressive. But they're actually deeply wrong. And the reason why that's the case is I think society teaches them that technology is either simple or it's really sophisticated, and it can't be both, right? Because as you add more features and more features and more features, the thing gets more and more and more complicated, and therefore harder to use. And I think the only thing that's happening there the thing that's not happening there is deep design. If you really, really, really think about your system deeply enough, for long enough, and usually your budget probably won't allow that. That's probably why people don't do it, because you need to keep adding the features. But if you were to have the luxury of the time to really deeply think about what you're doing, you could make it simple enough for 10-year-old children, any of your systems. And Sonic Pi is kind of proof of that, because I'll show you in a moment, but it's deeply, deeply complex, but it has an interface which is super simple. Here we've got concurrent code, we've got asynchronous messages, we've got all sorts of cool stuff. We've got a synthesizer running in the background using mathematics to make the sounds. These sounds are generated real time using this system called Super Collider, which is a really powerful, amazing synthesis engine. And one thing to notice here is that these all play at the same time. So if we want to make a melody, we need that one extra command, which is sleep, and then now we have a melody. And the cool thing about this is that, like with Logo, which was that language for teaching children how to code with robots drawing them around, or with pens, if you have pen down, pen up, forward, and rotate as your actions, you can draw any picture. Right? And the proof is that we have these automatic drawing machines that do this, right? And the dots and they draw the lines. And just with those 4 commands, you can draw any picture. With these 2 commands, you can make any melody. Any melody you've ever heard or will hear. And children do. My niece, when she was 6, I showed her this play and sleep. And the critical thing is to know that all you need to know, right, it's dead easy, is that higher numbers make higher sounds, and lower numbers. That's a good one. That's a good one. I like this one. Yeah, right? Lower numbers make lower sounds. And that's all you need to know. You don't need to know anything else. You don't need to know what F sharp, minor, whatever it is, diminutive nonsense. You don't need to know that. You just need to know about the property of numbers, that they're countable, and you can count up and you can count down. And the same for sleep, right? Sleep, a longer sleep time. Let's make this go to a really short one. I've done sleep 36. That's a very long time to sleep play. Yeah, or I can sleep for 0.3, like this, and shorter. That's really, and then maybe like 80 or something. They're very close after another, right? So longer sleep times, longer delay. Shorter sleep times, shorter delay. And that's it. That's all you need to know. And then off you go making your own music. And my niece, she was 6, her first piece of music with Sonic Pi was 100 lines long. I was like, wow, that's amazing. And she said, I've not finished yet. Off she was going, right? And this is the great, like you want to make things really low barrier to entry, but this is the problem. People look at this and go, wow, there's no way you can do what I just did earlier. But you've just seen me. Like, what is going on? And I think that it's weird that in software we have this sort of blindness to the fact that if we add enough design, we can make things simple. But there are lots of objects in the world which have exactly this property, and music is a great example. So if you look at a piano, I could teach any of you, if you've never seen a piano before, how to play all of the notes on a piano. Yeah? You just hit them all, right? That's it. That's how you do it. And I could teach you all how to play all of the strings of a guitar, right? You just strum it, right? It's really simple to start playing a musical instrument, like a guitar or a piano. But then you look at Jimi Hendrix, you're like, whoa, that's where I want to be. And there's a pathway to get you from picking up that guitar for the first time and strumming the strings to getting to be on stage performing like Jimmy if you put enough practice and effort in. And so there's no one questions the virtuosic complexity, the expressive amazingness of musical instruments like a guitar or a piano. Nobody questions that. And nobody questions the fact that they're also incredibly simple to start. And the only reason I think that they have this property is because they've had hundreds and hundreds and hundreds of years of evolution and design and iteration. And in the programming world, how many hundreds of years have we had? Right? So we're still really, really early on and where we are. And so this is important, right? These kind of properties where you can have a complex system which is hugely expressive, reveal itself as a simple thing, is just, in my opinion, a function of enough thought and design. And for me, that was a lot of walking around in hills. Well, I say hills, I was in Cambridge. There was a tiny little mound which I called the hill, and I could look over the stuff. But I used to walk in there every day for a few hours and really deeply think about the programs I was writing, and then the next day I would work on the features I'd thought about and then go for another walk. And that iteration of programming and walking was an amazing thing. And I really recommend it. If your jobs allow you to go for a walk during the day, they should. You'd actually really do some really interesting debugging and developments during that process of physical activity. So, where am I with this? So, I can show you a few things. One thing is that you can play samples, like let's do the bass drum house. Yeah. Make that louder. Yeah, let's do a loop. I'm jumping ahead. Loop. Sleep for half a beat and like this. Oh, I've got my BPMs at 174 because it's drum and bass mode. Let's go to 60. Right, cool. That's fun. I could also do something like loop amen. Let's do this. And then let's do guitar E minor ninth. Let's do that. Cool. That's nice. So let's do two of these. Right, one of those loops, and let's get the kick drum again. And we saw that before. And we play this code, and where's the kick drum? So this is a good interview question. If you can't figure it out, spend a little moment thinking about it. The reason why I put this code up is that whenever I give a workshop in schools, within an hour, someone's written this code. And we haven't taught them this. We've taught them loops. But they're like, oh, yeah, I've got the drums, I've got the bass. Surely I can do both at the same time, right? Surely. And so there was this time this girl put her hand up, and I walked over. It was the first time I'd seen this. And it was when I was working. So I was working in a school where there's an amazing teacher. She was called Carrie-Anne Philbin. This is the school, if I can, there we are. And that was where we were working in, that's Carrie-Anne there. And so one of these pupils put her hand up. And in the early days, we were iteratively developing Sonic Pi. So it's hilarious. I had like an opportunity to do a 3-month project at the University of Cambridge for teaching kids how to code alongside the Raspberry Pi Foundation, running on the Raspberry Pi computer. And I thought it was a really ambitious task to build a sort of a programming language to teach kids how to code in 3 months. That's what the budget was. And I was like, okay, that's a really high ordeal. I'll give that a crack. And then in the first meeting, they were like, no, we need you to design the language, to implement the language. You need to find a school and a teacher. We need you to develop a scheme of work to teach computer science and evaluate it in 3 months. So that's what I did. And so when you've got like 3 months to do that, you think, well, I'm not going to blow the 3 months on development. So the first version of Sonic Pi was 2 weeks worth of work. What is the smallest possible, tiniest thing I can actually go into a classroom and engage with schools? And actually that was literally this, or no, the play and sleep thing, this stuff, right? and sequential programming. So we were able to teach like programs have an order. But yeah, so we were in this school. This kid puts her hand up, and I go over to her. And we're at the time where every week I'm basically building a new version of Sonic Pi. So I had that first 2 weeks version that did nothing really, but enough to teach the first lesson. And then at the end of the lesson, I have like a retrospective with Carrie-Anne, and we'd say, what should we teach next week? We look at the curriculum and we figure out what we're going to teach. Then I would go home and frantically develop the next version and then bring it into the school that week. And then we did that for 7 weeks. And so it was about week 5, I think it was, week 4, we taught the loops. And this girl had done the 2 loops, and she'd put her hand up and says, why can't I play the drums at the same time as the bass? And I'm like, oh, yeah. And do you know why you can't do that? Why that's not going to work? Because it's a single-threaded application. So we start at the top, we enter that first loop, and we stay there forever. Loops are like black holes for code. They suck in the program and just keep it there forever. And so we never get down here because we're always stuck in that first loop. So I looked at this, I was like, okay, right, threads obviously is what we need to teach. So I said to Carrie-Anne, can we teach threads next week? I'll chuck it in. And she said, that sounds great. And I said, is it on the curriculum? She said, is it on the curriculum? So I looked at the curriculum. It's got like lists and data structures and algorithms and yada, yada, yada. But of course it doesn't say threads. And I said, no, it doesn't. And she said, oh, we can't do it then. So I went to this girl and I said, I'm terribly sorry. If you want to play the drums and the bass at the same time, you're going to have to wait till you're 18. Because then you can go to university and then they'll teach you threads and threading a university computer science degree. And it sounds funny, but it was a heartbreaking moment. Because I don't know if you've ever been into a school to teach computer science, and if you haven't, really find a way to get into school to help, because they're really desperate for actual experts like you. And finding a way, getting into a school and getting them to actually listen to you is hard. Right? Get them to focus is hard. Get them to engage in the actual thing you're doing is really hard. So having a student like this girl who put her hand up that not only had engaged and listened and was focused, she'd actually innovated. She'd thought, well, why couldn't I do 2 loops? Which was like a beautiful thing. It's like that's the thing that you want to grab and flourish. It's like the little plant had grown out of the floor, and it was like peeking its head up, and the leaves were just seeing the sun for the first time. And I literally went, sorry, not yet. And she instantly switched off. What kind of crap piece of music software doesn't let me play the drums at the same time as the bass, right? This was hilariously and so annoying. So this is where you get a choice. Do you follow this actual sensible path, and the one where the project and the funding told you to do, build a language to teach computer science that maps onto the UK computer science curriculum, which is what I was actually tasked to do and what the funding was for? Or do you actually do the actual real thing, which is get the kids coding? Screw all that bit, that's there, but actually getting the kid to actually do stuff, allowing them to play the drums at the same time as the bass so they carry on rather than switch off. And so I had a dilemma, and so I was like, okay, I'm going to do my own thing. I'm going to actually pull the wool over the teacher's eyes, and so the next week we had a different kind of loop. It's called a live loop, and the live loop cunningly has threads. It is threaded, so it works, right? And so you go to the schools and say, in Sonic Pi, loops are called live loops. Oh, fine, that's a bit weird. Okay, cool, and they just happen to work as expected. So the teacher can teach a loop as a repeating thing on its own, but when the child thinks innovatively and adds a new one, it just works. So this is what we can do as programmers. Like, we don't have to go loop, that's done. That's a thing. We don't have to do any more kind of loops. We can create our own kind of loops. We can develop our own languages, and we can take the languages into directions that we want to. That's the incredible power we have as programmers. We really are magicians with language, and we can really use that power to interesting ways. And so it turned out to me that actually what I discovered was that with Sonic Pi that it wasn't about teaching the computer science. That's not hard at all. It's not hard at all. And building a tool to teach computer science is not hard. What's hard is getting that engagement, getting the kids to care, getting them to want to do it at home so they can play around, like they play around with Minecraft. And that was, to me, the really hard thing. And so I spent the whole time in that project, and in the early days, sneaking in things that the children wanted, but in a way that didn't disrupt the basic teaching of the computer science, against the sort of the thrust of the direction of the project. So that caused a lot of tensions. But I would do it again in a heartbeat, because what it enabled is what I've just done. And even more than that, I'll show you in a moment. And so it's really important to think about that, think about how we can break out of these barriers and change things. And so I imagined a world, actually, when I was building this. It was like, okay, this is not just a tool for teaching computer science. This is a tool for engaging kids in computer science. And if we want to engage kids in computer science like a musical instrument, well, we need to have the Jimi Hendrix. We need to have the Jimi Hendrix of computer science. Who is it? Is it Bill Gates? Mark Zuckerberg? Really? No, it's not, is it? Right? It's people like Sarah Davis. So she's performing in New York here to this crowd of people, and she's using Sonic Pi. They're all seeing a professional programmer perform live on stage writing concurrent. You laughed earlier about the threads. Sarah's live coding concurrent programs in front of that audience. If you get a bit nervous doing your stand-up with 3 other people, yeah? And I think these people are seeing that for the first time, many of them, an actual programmer at work. Because we've all seen how ludicrous the social perspective of programming is. We know that. We can look at TV programs and see the spinning cubes and the crazy nonsense that look like the Matrix when we have a programmer on the screen. It's not real at all. And then you look at this and you go, well, that's also not real, but it is. It's really real. And she's doing a really great job of helping to change that social perspective. And I think this is really, really important. And so this was in my head. How do we imagine this? And we have it, right? So this has been a beautiful thing to watch happen. So where do we go from here? A few things I want to show you, like before I move on to new things, because it's like quite nice to show. This software is free. It's open source. It runs on Linux. It runs on Mac. It runs on Raspberry Pi. It runs on Windows. It's really important. And every time I go to conferences and talk about Windows, people go, "Wow, that's pointless." It's the most important operating system because everyone else uses it. And that's really important. If we want to care about talking and communicating and sharing our ideas and thoughts and worlds with the other people, we have to use what they use too. And we have to not mock them. Really, it's really important. So all our tools, we should really be thinking about this deeply. And so, yeah, let's think about where we can go with this. So one fun thing was that let's show some MIDI stuff. So I showed that you can play note 70. But I can also call MIDI note 70. That doesn't do anything. That's because, actually, I've got a little light on my synthesizer here, which is flashing. And what I can do is I can actually ask Sonic Pi to play the live audio of the Moog synthesizer, amplitude 4, and maybe it's not going to work now. Oh, there we are, yeah. Oh, cool. And then I can then make a live loop, call it foo, play MIDI note 70, sleep for 0.25 seconds, make this have a sustain of not short, and oh, it's doing some weirdness. It's out of tune with itself. Do some octaves. Let's do octaves, 73 of those, tick through that. I'm going to take it out and put it back in again. I think it's got into itself in a bad state. Let's go down to like 60. So I'm using the same code to actually trigger synthesizers. So we can use this with any MIDI synthesizer in the world. It's super fun to play with. And did you notice? Let's go for like C3. I'm able to change the code, and it just updates automatically. So these live loops don't just do concurrency, they also do live updating, and that's where the performance starts to come into play. And I can create another live loop called bar. I can synchronize it with foo, and I can sleep for 8, say, for those ones. And I can play a sample. Let's play the E-bit beat 7. Let's beat stretch that to 8. And off we go, right? And so I can spawn another thread concurrently with the music. But there's one thing that maybe you haven't actually really clocked. Clocked is a good pun here. Concurrency is about things running at the same time, right? Parallel is really at the same time. Concurrency is a pretend, like it could be at the same time. But from a cognitive perspective, it's running at the same time. This isn't just doing that. You can imagine a band, right, like a free jazz band, where you say, off you go, and they don't even look at each other, and there's no communication. One person's playing fast, one person's playing slow. That's at the same time, but it's not like a band that's tight and cohesive. And sometimes you might want that. You might want the drums to be playing at the same tempo as the bass. Usually you want that. So concurrency is not enough. We don't just want at the same time, we want in time. So these live loops, they play in time with each other, and that's really exciting. So there we go. I could show you more, but I would like to show you other things too. And I'd like to talk about where this is going to go. So I've spent like 13 years working on the software now, and it's pretty feature complete. I'm pretty happy with it, but there are some fundamentally important limitations to what it can do and stopping me going further forward. So the first thing is it's really now turned into a big ball of tech debt. So as these things do, what I turned out to implement when I built my first play, sleep, it was very simple code, but it started adding the threads and started adding really complex things like adding reverb around threads. So using lexical closures, and then I've got to scope the threads inside there. And I've got to essentially I created a whole new threading model on top of Ruby to enable me to do this. And I've got these trees of threads that I'm maintaining and monitoring that I can actually do a depth-first traversal through and kill the threads that I want to for that particular thing and keep those ones running. And turns out languages exist to do this already. And there's a really beautiful language called Erlang. And it runs on this VM called the Beam. And that has a library called OTP, which is essentially what I've built in Sonic Pi, but much, much better and much more reliable. And it turned out then, I was showing all these live coding things to people around the world, I managed to make a friend. This is the late and great Joe Armstrong, performing with Sonic Pi, so it's not just Sarah Davis. And he was super interested in what I was doing. And he was like, yes, we can totally build this in Erlang. And he implemented the first I/O system. So all the MIDI stuff that you just heard then is flowing through Erlang that Joe wrote. And so in my head, it's like, this is definitely the way forward. If I were to rewrite Sonic Pi, I would totally use the Beam as the sort of fundamental platform. But also, then Erlang has some issues as well. It's an interesting language. It has a history from Prolog, so the syntax is like that. It's very unlike anything else you've ever heard. And there's an amazing guy called José Valim, and he implemented a language called Elixir, which has a syntax like Ruby, but I think a lot of people think that it's therefore is Ruby. It's not at all. It's more like Erlang, and Clojure as well. And it's a beautiful language with an amazing community of people with amazing tools. So this is my mind. I need to build something that is implemented in Elixir that runs on the Beam that goes forward. And so I had this amazing opportunity to work with the University of Sheffield and this amazing, one of my favorite bands called the Black Dog. If anyone's ever heard of the Black Dog? They're like an old techno band. They were in the early days of Warp record labels, so Aphex Twin and Plaid. They were all in the same sort of melting pot. And they're still going, still making amazing music. And last year, they did a performance, and they used some weird software that this guy had written. And this was my first experiment of how could I build something in Elixir, that ran on the Beam, that solved the problems I had. And so what were these problems? what are the problems of Sonic Pi? Well, the first one is I put a huge amount of effort into making this thing run on Windows and have an installer and sign the installer cryptographically. So schools didn't have any sort of problem about installing it, but they still did have a big problem. It's really hard to get schools to install software on their computers. Sometimes the schools don't even have the ability to install software on their computers because it's managed externally by some council or something. And so that was that's a massive technical barrier. Well, it's not a technical barrier, it's a social barrier, political barrier to getting things into schools. The second thing is that wouldn't it be really nice? I don't know if anyone had a look at Scratch, the programming language Scratch for kids. But one of the best things about Scratch is this is a big website with millions of programs that kids have written. And my kids love it because they can go and search other people's programs, they can play their games, or they can watch their animations, or whatever the thing does, and then they can double-click it, and they can open up the source, and they can read it, and they can grab the bits they like, and then they can mash up their own project. This is amazing. I wanted this for Sonic Pi, and people all keep telling me, why don't you have this for Sonic Pi? But we have a real problem of security, because in Sonic Pi, I mean, it's just Ruby, or it could be any language, and now I could do like, I'm not going to do that, right? And if that code is in there, it will delete all the files on my file system, which is a problem. So you've got to trust the code you evaluate. If you're pulling code from random places and running it on your computer, you've definitely got to triage it. You've got to look at it. And so if I were to make a website like this, I would be the person responsible for looking at every single thing and making sure it's safe, which obviously I can't do. Or I'd have to sandbox Ruby, which is a non-trivial thing as well. So being able to grow the project in terms of having a big corpus of examples is a fundamental limitation of Sonic Pi because of its model of security. If I switch to Python or Java or any other language that you traditionally know about, except for JavaScript, I guess, you have the same problem. So I needed to switch to another language. And then the other thing I want to work on is collaborative jamming. So in Sonic Pi, I've already got jamming in the same room. I've got this button at the bottom here called Link. You can click that. It uses an amazing technology called Ableton Link, which synchronizes all of the Sonic Pis running on your local network automatically with tempo. And if one person makes the tempo faster, it makes it faster for everyone. And the cool thing about Ableton Link is it's not technology that I implemented. This amazing company called Ableton, who make professional DJ production software, it's in that as well. So the production people using Ableton can also synchronize with Sonic Pi. And there's hardware and VJ software, all that use the same protocol. So suddenly everything in the room can work in time with each other, which is beautiful. But I'm also interested in going back to the UK and then jamming with you guys in the States or in Finland or in the Netherlands or wherever you're from, and being able to have people jam together all over the globe. So distributed jamming seems a really interesting thing. So I wanted distributed jamming, I wanted security, and I wanted to not have an MSI installer for Windows, which means it needs to be web-based. So how am I going to do this? So I then spent a bunch of time working with this Black Dog and the University of Sheffield, and I built this system called Bleep. And here's Bleep, see if it will load up, see if the web works. My phone's connected. This is running on a server in Sheffield in the UK. I can click on one of the compositions, and these are all compositions that the Black Dog did. And this is a Phoenix Live View application. If anyone's not looked at Phoenix, and specifically Live View, which is an amazing technology, implemented in Elixir that runs on the Beam, that essentially makes sure that every client, every user, every web browser has an active WebSocket back to the server. Now, this sounds crazy. Like, when you think about web programming, normally you have a web server, right, and multiple connections. But in the Elixir Erlang world, you have multiple connections and multiple web servers. Everyone has their own web server because concurrency is so beautiful on that system that it makes all that really, really beautifully trivial. And so it has the technology that makes it super trivial to have a gazillion WebSockets open at the same time and manage them all flawlessly. It hasn't got to pool them and work around them, who's got the thing and who's the state, it just has a WebSocket per client and keeps it open. So right now I have a WebSocket client connected to Sheffield, and The code in these boxes is in a language called Lua. So this is my choice for the security. Lua is an amazing embedded language. So it's designed to be hosted in C++ or in Java or in all sorts of languages. JavaScript has it, and this is a specific one for Erlang. It's called LuErl, made by Robert Verding, who was also a co-creator of Erlang. And when I press this Q button, it's going to essentially send the code in my browser to Sheffield, and it's going to run the code on the server in Sheffield in a sandbox, which is then going to generate events to ship back to my browser to then trigger the audio synthesis engine that Guy Brown, who was the head of computer science at Sheffield, designed. And the cool bit is the code was written by the black dog. So let's listen to this. Oh, is it going to play? Oh, it's playing out of my my speaker, so I can hear it, but you can't. Why is that? You would have thought it would go through the sound system. Is it? Oh no, it's because I'm using a really weird USB connection. I can't actually play this sound. Maybe I can quickly. I'll spend 2 seconds, and if I can't get it working, let's go for this again. See if I can make it make sound. It's doing the sound there. Oh, it should be playing. But no, it's making sounds there. No, okay. I'm not going to debug this live on stage. You can play this at home. It's a shame. But there's a beautiful sound by the black dog. It's not working. But yeah, it was a really good opportunity to explore the idea of what would it be like to build a web system where the code ran on the server and generated events and got them sent back to the browser. I'm really sorry you can't hear it. It's just they haven't given me an analog audio connection, and I set it up for the performance earlier. And I didn't test this. I should have done. But yeah, this is a really beautiful thing. And so this was like, build an experimental thing, see if it works, and then think about how can I actually go forward with this. So the next thing I did, sorry you can't hear it, is then I built I did a performance in an underground bunker in Finland. It was brilliant. I'm like, I want to be able to do that again. But if I have to have a WebSocket connection back to Sheffield, it's not going to work, right? There might not be any signal, so I can't do that. So I made it as a app. See if it's going to work. Here we are. And that's there, and so it's the same thing, but this is running on my machine. So this is like Electron, where you have a Chromium browser and Node.js banged together, and you can essentially use web technologies and the whole sort of web approach to development to make a desktop app. But this is not using Node.js. I'm not using that nonsense, or NPM and stuff like that. It's using the Beam, and it's using Elixir. And it's essentially that what I just showed you that didn't make any sound, but playing locally. Will this make sound? It probably won't either. Oh, it does. This one works. Why is that? Anyway, who knows? I'm not actually playing anything now. This is a terrible demo. Terrible demo. Let's refresh. Let's try a different one. Let's try this one. There we are, nice. So you can sit and listen to this all day. It's nice to sit on the train, listen to the black dog, change the code a bit, and you're working with them. But this is running locally on my machine. So this is the next stop. So first of all, thinking about building something for the web, then can I make it for the application? And so I got that. And so then I've started thinking about how do I take this forwards? And so that I took all these ideas, and Sonic Pi has been my last 12, 13 years of development. What is the next 12 or 13 years of development? And so I want to keep Sonic Pi going. It's got people using it in schools. It's amazing. There's loads of books about it, and teachers have written schemes of work to teach it. This morning I got an email from a teacher in Italy, and he was telling me about his latest stuff he was doing, which is super cool. So that's really great, and I want to support that. But I also want to actually start experimenting and doing interesting things. And one of the interesting things I want to do is obviously solving the security problem, making it work on the web. So this is what this system called Bleep does. But I also wanted to think about the full performance with visuals. Now, there's really cool visual tools. There's an amazing one called Hydra. I don't know if you've ever heard of this, by a lady called Olivia Jack. It's a beautiful system where she's essentially built a DSL in JavaScript, which compiles down to GLSL shaders. Here's one running in the background. And she's done this ridiculous thing where it always looks cool, which is what you want. And so this is running in the browser, and you can see the code here. I can jump around and flick around. There's some really cool things. So I was like, I want to have that kind of thing in my environment, just running by default. So that was the first thing I've started working on. So how do I take the ideas from Sonic Pi, this Bleak thing I've showed you, which was an experimental platform which I worked with the Black Dog, and build a thing for the future? So I've started a project called Tau5. And the name comes because I was working on Sonic Pi version 5, and we all know that tau is a better constant than pi. So this is where that comes from. And so Tau5 runs, again, I've built it in a way that I'm building it from the ground up. So I haven't really got too much to show you other than really quite sophisticated developer tools. But because it's a developer conference, I think that's going to be okay. So what I've done is I've built, so here's the other thing is that it works with AI. And so if you're working with AI agents, you definitely want to be working in a VM, in a sandbox. You don't want to run the agent on your actual machine. Who does that? Please don't. Please, please don't. Please don't connect the agent to your emails. Please don't connect. Don't do that. Don't. Run it in a sandbox. And so here's a Linux VM. I'm going to run my start Tau5. Does a background thing. The cube spins around. It's pretty cool. And I've started off with, this is Hydra running in the background. So this is using the same technology I just showed you with seclusion, whereas running this Hydra in the browser. I've got no text editor yet. I've played around with it. I've built experimental things, but I've deleted them. I spend a lot of time building stuff and deleting it. I think it's really actually a very good process. Because if you build it 4 or 5 times and delete it, the 6th time you build it is way better than the first time you build it. Really honestly, the older I get, the more I'm happy just to delete and start again, Because it's not like I'm going backwards. I'm staying at the same place until I feel confident that I'm leaping forwards. And that's really quite a positive thing. So here we are. And what I did with it so far is, because I'm experimenting with security, and I wanted something that actually works where I can take anyone's code and run it on my machine, that sounds like a good space for AI agents, because who trusts them? Nobody. So it'd be good to have them work in a sensible sandbox environment to see if that actually makes sense. So what I did is, in the development version, I added terminals. So here's some terminals. These are all removed in the production version. And so I can call Claude here. And Claude's there. Hi, Claude. Is that readable? Do I need to make it bigger? Can you read that? So, hi, Claude. I don't know about you. I always start off with hi, Claude. So, hi, Claude. How are you? No. Could you please update the Hydra sketch using, well, actually, what am I using? So before I do that, I have built inside of here really sophisticated developer tools. So this is the standard Chromium dev tools. Notice that the font is much nicer than you normally get. When you build your own browser, you get to inject stuff. It's cool. So I made it look nicer. And that all works. That's a beautiful thing. So I can highlight things, I can right-click, and I can inspect the element, and it jumps to, like you normally expect with a browser. But because it's also not just a browser, it's also the Phoenix Live View Elixir world as well, they've made their really cool tool called the Phoenix Live Dashboard. And that gives you great introspection to what's actually happening inside the beam. How many processes are running? How many applications are running? What are they doing? What are their PIDs? So I now have visual deep introspection to the server part of the system, as well as deep visual inspection to the graphical part of the system, which is really interesting. Another thing I wanted to add is, well, not only do I want to deeply inspect things, but I want to actually go and manipulate things. I want to REPL. So I built a REPL for Elixir, which allows me to type Elixir code. There's a number back, brilliant. You trust me that it is Elixir. And so that then allows me to then modify and interact with the runtime system live, which is really useful for development. So that's there. Then I also have a bunch of logs. I have information about how it all started. I've got the beam log, that's the server log. I've got the log for the GUI. Then I've got these three other things, and this is what I want to talk about now, which is the MCP servers. So I started adding bunches of MCP servers. They're great. And so I've got an MCP server for Elixir, that's Tidewave, which is also written by José. So I think it's really interesting that the language developer has not just developed the language, but has developed the MCP tool for the language. I think that's a really powerful combination. And also Elixir is really great, actually, it turns out, for MCP, because MCP wants context. And what context would you have? Well, the documentation. Well, the Elixir includes the documentation as part of the packages. So actually, all the information is already there. So I think it's an interesting combination. And that's the Tidewave. And then for the Chromium stuff, so that's effectively the Elixir REPL. Now the agent can write code in the Elixir REPL automatically and look up source code, look up the documentation, all that good stuff, look at the logs. But then also we have the Chromium thing. We have the developer browser. And that has those amazing tools for inspecting the console, inspecting the network tab. And I have built MCP tools for all of those too. So the agent can look at all of that. And then I built another MCP server, which then acted as an aggregate one. So I only have to have one, and then it is able to call all these different other MCP tools, and you just need to have one. And I call that Spectra. I thought that was a fun name. And so, yeah, it's going back to Spectra over here. I can say, hi, Claude, could you please, let's type could correctly, update the Hydra sketch using Spectra to make it fun? Let's try that. See what happens. Is it going to work? Is it going to work? This is where my hands are very sweaty. It's doing some thinking. Is it going to work? I'll update the Hydra sketch to make it more fun and visually interesting using the Spectra tool. Wrangling. Oh, no. It's because, okay, hold on. Let me just start this again. There is an issue with the fact that all those browser tabs I showed you are all browser tabs. And the Chromium DevTools isn't able to somehow differentiate between the one you last selected and the one that is the main one. I haven't figured this out yet, so let's just try this again. Without going to the DevTools, going straight into this, and calling Claude. Hi, Claude. Can you use Hydra, update Hydra to make it like a GOTO conference presentation? What on earth would that look like? Let's see, it's jitterbugging. I'll update the Hydra visual to create a professional conference presentation aesthetic with clear modern visuals suitable for a tech conference. Now, hands are super sweaty because it didn't work last time. Oh, well. I'm sorry, GOTO conference. That's rubbish. Make it way better, please. See what happens. I'll create something more dynamic and impressive. A proper conference quality visual that's bold and engaging. Well, what's it going to do? But whilst it's thinking and doing its stuff, I think this is a really interesting use of AI because I don't care about determinism here. I really care about exploring and experimenting and just trying things. And it's, actually, that's pretty nice. Ooh, hey. It's gone. Ooh, there we go. And so you can look at that and you can can you make that more green? And see if it does that. And so this is a really interesting thing. It'll show you the code is written and you can start to work and explore that. Is it going to make it green? Let's see. Is it going to make it green? Is it going to make it green? Come on, you can do this. It's using all the tokens. That is a problem, actually. When you add all these MCP servers, it uses all the tokens. Hasn't made it more green. Much better suited for technical conference with that classical green terminal matrix feel. Oh, he's made the circle green. There we go. There we go. Oh, nice. Thank you, Claude. But can you see where I'm going with this, right? So this is the starting point, right? I've built the foundations. I've got dev tools. I've got app. This works on Windows. It works on Linux. It runs on a Raspberry Pi. The continuous integration on GitHub will build an app image for Linux as part of its test running situation. So I can just download that and run it on my Raspberry Pi. And it's starting to now hook up with Hydra and all the other stuff, the sound stuff, the bleep stuff. I know I can build those, so I'm kind of leaving them to the side, and I'm building the other stuff first, getting that working, and then I'll bring it across. Have a GUI here. I was thinking about how I might sort of break it up into sort of windows. So I've got like a Tmux-like environment here. So that could be the editor up there. There could be some logs there and some styles and sliders on the right-hand side. And you will be able to write your own interfaces. This is the thing. Like, I don't want to have one interface. I want people to be able to easily use this Lua code to work on it. And I've even got like a Lua terminal here, which is writing the Lua code and running it on my server and working quite nicely. I mean, let's see. And it's got a few things which are interesting. I've got 20 seconds left. Let's show you these couple of things which are important for security, right? So Lua is sandboxed, and it's a normal language. So let's like look at this Lua code here. I can capitalize a word, which is great. That's a win. But there's also a few other things. Like, what happens if I were to run a infinite loop? So this is I need to have a lowercase w there. It doesn't let me do it, right? It actually gives each execution 30 milliseconds of time. And if it takes longer than 30 milliseconds, dead. And then the other one I want to show you is, what happens if I were to then make a string which kept growing and growing and growing and growing and growing? So I'm doing denial of service attacks here on myself. The first one was denial of service attack on CPU. This is a denial of service attack on memory. And I run that, and it's like, no, sorry, you've used too much memory. So I've really, really tried my best to actually make this secure and sandboxed. So I'm happy for the agents to play in this space. The stuff I was showing you before with all the other agent stuff is just for development. I've got the Spectra tool for development, but I've got a Lua sandboxed MCP tool for users, so I don't have to worry about security. And that security is such an important thing to think about when we're talking about AI. We need to be talking about it all the time. So there we go. That's where I'm at. I just wanted to say thank you so much for listening, especially on the last day of the conference. I hope you're having a really great day. And I would really, really recommend you spend time thinking about how you can use your amazing creative powers as programmers. Build the future of tomorrow. Build a future we want to live in. Build a future where code is not just a tool for business, but it's also a tool for human expression, so that you can go to the parties and say you're a programmer and have an interesting conversation and talk about the cool stuff that you're doing, and they can also talk about the cool stuff they're doing. And it'll be a beautiful time. We'll all have a great time. Thank you so much for having me. I'll see you around.